I'm your host, Nick Jikomis, and today I'm speaking with Dr. Iain Oswald. Iain has a PhD in chemistry from the University of Texas, Dallas, and he is principal scientist at Abstrax Technologies, a cannabis research and product development company. He's an expert in using cutting-edge analytical chemistry techniques to study plant chemistry and has done a lot of work to decipher the chemistry of commercial cannabis, including lesser-known compounds found in its essential oils, and how these relate to the sensory qualities of marijuana. We talked about the aroma of cannabis and the chemical compounds that dictate different aspects of its aroma, consumer preferences when it comes to aroma of marijuana, terpenes, which are volatile compounds abundant in the plant world, his research on volatile sulfur compounds, which are found in nature in things like garlic or in the aerosols produced by skunks, and how lesser-known cannabis compounds in this chemical family relate to some of the pungent, gassy, or skunky odors that are commonly described for cannabis. And we also talked about his journey from academia into the private sector and what's on the horizon for cannabis research. So if you're interested in cannabis varieties, the different types of marijuana strains that are out there, how the aromas vary across these varieties, and what the chemistry is behind different aspects of cannabis aroma, and how all of these things relate and tie in together in terms of how cannabis is classified and the properties and effects it might have, this will be a really interesting episode for you. Iain shared a lot of really cool stuff from some recent research that he's done, that I've done, that others have done, that really starts, or at least begins, to make sense of some of the major outstanding questions about commercial cannabis chemistry. As always, if you enjoy the content I'm producing, please like, share, and subscribe. Don't forget to sign up for the free weekly Mind and Matter newsletter at mindandmatter.substack.com, and check out the links in the episode description if you want to check out some of the research that we cited in this episode, or you want to learn how you can support the podcast further. Hey everyone, I want to take a minute to tell you about a product I use called Everyday Dose. They have created excellent coffee and matcha products with functional mushrooms and other supplements and less caffeine than traditional coffee or matcha products. I actually reached out to them because I've been using their product for about a year or so, and listeners often ask me about my daily and weekly diet habits. They make a really good mushroom-based coffee alternative. It contains micronutrients with antioxidant and anti-inflammatory properties, as well as collagen protein to help support healthier skin, nails, hair, and joints, and the amino acid L-theanine from tea leaves. Each cup has just about 39 milligrams of caffeine. That helps eliminate the caffeine crash that can come if you drink regular coffee, which has much higher caffeine levels. And they use a unique cold extraction process that results in lower acidity than normal coffee. And the caffeine microdose makes it suitable even for someone who doesn't normally drink coffee. This mushroom-based product is made using a double extraction from 100% mushroom fruiting bodies like lion's mane and chaga to maximize the extraction of micronutrients like beta-glucans, triterpenes, and sterols. Other brands don't typically do this, making Everyday Dose one of the highest quality products of its kind. It's gluten, dairy, and nut-free. There's no added sugar. It's paleo and keto-friendly and made with kosher ingredients. There are no grains or fillers, and it is lab-tested to ensure quality. I really like the taste of Everyday Dose compared to black coffee and other mushroom coffees, and they have a mushroom matcha product loaded with functional mushrooms and collagen proteins, so if you like green tea matcha, you'll probably like that product too. If you're interested in a healthy coffee alternative, I highly recommend giving Everyday Dose a try. Check out the link in the episode description or visit everydaydose.com to learn more. If you go there, you can find special offers that they have for getting a free frother and free travel pack of on-the-go doses with your purchase. Hey everyone, I want to take a minute to tell you about a really cool health monitoring device I've been using for several weeks. It's called Lumen, and it's a handheld, pocket-sized device with a sleek design. It measures CO2 levels in your breath, which allows their technology to determine the extent to which your body is burning fats versus carbohydrates. Lumen helps improve your metabolic flexibility, your body's efficiency in shifting between using fats and carbs. It improves your ability to burn fat, which decreases your hunger levels and makes your body less dependent on snacking, and it can increase your energy levels by helping you develop a high-functioning metabolism. I use this device in the morning, before bed, and after meals and workouts to track my metabolism. With just a couple weeks of use, I learned a lot about which foods were causing my body to burn mostly fat, mostly carbs, or both, as well as how long I need to fast each day to promote fat burning. Lumen is great for anyone looking to optimize their health for either weight loss or athletic performance. The easy-to-use app allows you to track your results together with what you're eating and how you're exercising, and it syncs with other devices like the Apple Watch. Click the link in the episode description to learn more and use the code MIND, M-I-N-D, in all capital letters to get $50 off your Lumen device today. And with that, Here's my conversation with Dr. Iain Oswald.
Yeah, sure. So my name's Iain Oswald, and I'm a chemist by training. I have a pretty diverse background from the academic world in that respect. So I started out doing research back in 2009 and 10 as an undergraduate at the University of North Texas. And I was working under the tutelage of Professor Muhammad Omari, who focused on developing new types of phosphorescent materials, understanding the electronic properties of those. And so I got to do a lot of inorganic synthesis, organic synthesis, as well as a lot of spectroscopic type of techniques to kind of understand the electronic properties of those. So that gave me a good kind of background into, the world of organic chemistry and how those can be applied for kind of the applications. From there, I did a master's with him for 2 years, kind of continuing the work I was working on as an undergraduate. We were able to file some patents, as well as publish a few papers around these cool phosphors that we developed. I then went to the University of Texas at Dallas in 2014 or 2013, sorry. And I worked on solid state chemistry. And so basically we were developing new types of materials with these exotic electronic and magnetic properties that in the future could have some potential use. But right now they're still kind of self-contained in the physics world, trying to understand how they work and how they can be applied to new sort of technologies. And then from there, I did 4 years there. Then I went to do a postdoc at the Colorado State University. And when I was there, I was working on these hybrid organic inorganic perovskites. And so you may have heard of these materials. These are, again, solid state materials, but they're excellent chromophores. And so they make really good solar cells. And so they've been around now for about 10, 15 years. And I was involved in helping understand some of the really detailed chemistry surrounding them, because they're kind of fascinating materials where they act like really good semiconductors, but they have none of the chemical characteristics of, say, silicon or germanium, those sort of things. So anyway, I did a little bit of work there. So a lot of different cool experimental techniques we used. We did a lot of neutron scattering at national labs, that sort of thing. And then when I was finishing that up, I was applying for different positions in industry. I had decided I want to get out of academics. I think it had kind of run its course. I think my brain works in too much of a creative application manner for academics. And so my good buddy, TJ, who's actually the VP of research here at Abstrax, called me up around the same time that I was looking for different positions. And so he kind of explained to me very generally about what Abstrax was starting to do. And it was only about a year and a half old at the time. And that's really involved in basically, developing flavor and fragrance applications off of using cannabis kind of as that base, profile that we're after. And so since then it's expanded to many different types of projects. We have, obviously our core business is focused around understanding the aroma of cannabis and, creating products around that. But also, this has led us to do some really cool other work, such as, we have some cultivation studies going right now. So kind of going into more of the breeding aspect of cannabis. And so we have a lot of different sort of, fields that we're looking into surrounding cannabis, but it's also been expanded beyond that as well. So we're now looking into hops and other botanical flowers, as well as other types of products that consumers use all the time, probably throughout the day. And, really trying to understand what makes these products have a certain quality to them and understanding that on a chemical level. And so that's where I come in. Really, I'm basically leading the team in the lab for the most part, doing the actual hard science. And again, because we're interested essentially what makes things taste a certain way or smell a certain way, one of the key technologies that we use is this 2-dimensional gas chromatography system at Abstrax. And so, they invested in that early on, and I've helped develop that technology throughout the years. And really, it gives us kind of the key information to understand what we want to, both in cannabis, hops, as well as other sort of products that we're trying to understand.
So why do you guys have such a focus on the aroma of cannabis? Why is that important?
Yeah. So I think there's two parts to it. I think when the company first started, Kevin, Jack, and Max, they're the owners. They started the company in 2018. I think they recognized that there was a severe lack of understanding as to the chemistry behind the aroma of cannabis. And so because of that, they saw, from a market standpoint, that there could be some sort of, angle there. But also, as I'm sure you're aware, Nick, the aroma of cannabis can kind of dictate, it's hypothesized to potentially dictate kind of how a product may influence the psychoactive properties of cannabis. And so a lot of folks have been studying cannabinoids, on a routine basis. And so, that field at the time felt kind of saturated. And so I think, the angle of kind of looking at, well, what is all the other chemistry that's occurring in cannabis? What's going on there? How can we kind of educate the consumers as well as, build a market around that? How can we do that in a way that's, really diving deep into the chemistry behind it? And so that was really the main goal, I think, when the company was first started.
And, where does the aroma actually come from in cannabis? Typically people talk about these things called terpenes. And so what kind of contribution are the terpenes making to the aroma? And, what are some of the question marks there?
Yeah. And so this is a great question, and one that, we've been hammering away at everything but terpenes, but that's not to say terpenes aren't important at all. As you showed in your paper, there's a wide variety of kind of major terps that can produce the aroma of cannabis, but they don't necessarily describe the aromas as specifically as we'd like. And one aspect of that is, for a long time, people didn't really understand that what people call gassy cannabis or skunky cannabis, that smell that everybody kind of knows. There was not a clear understanding about what is the chemistry behind that specific aroma that cannabis produces. And so again, kind of going back to how I was saying that a lot of folks were, Abstrax started trying to look at, what can we do differently that other people are not looking at? Well, within the aroma of cannabis, like you mentioned, a lot of folks were looking at terpenes. And the main reason that is because they are the most, the highest concentration compounds, in the volatiles in cannabis. And so, those include beta myrcene. They're typically very high in OGs. Hemp is almost always myrcene rich. You have caryophyllene, which is a sesquiterpene. It has a more muted aroma because it is heavier. It's a larger molecule than beta myrcene or, the pinene. But it's in many different things as well. Limonene, D-limonene, we see that in basically every variety, and it can be dominant, typically in hybrid varieties. They tend to be present in greater concentrations, or at least what people would consider to be hybrid. And then, linalool, geraniol, you see all these sort of things. And I do want to say something here. I think this is, the terpene world. I think there's some, not necessarily misinformation, but people may be kind of like assuming things that are not necessarily correct. And that is that if you do not see some of these terpenes on a COA label or on the packaging label of your product, does not mean that those other things are not there. And so what I mean by that is, in our analysis using this 2DGC, we've optimized the methodology to basically have a very wide dynamic range to see all the high concentration compounds and low concentration compounds. And I'll explain why the low ones matter just as much as the high ones in a bit. But we basically always see, if you have a COA that says we test for 18 terpenes, oftentimes we'll get these tested at a third-party lab just to see what they say things look like. And they'll have a lot of non-detects for many of these compounds. But what we find is actually they're almost universally in these varieties. They're just in levels that are a bit too low, maybe for their methodology to see. But the way we work, we want to see that whole range. And so we've tuned our methodology to see it. And so that is something I want to mention, that I do think there's this, kind of misconception that if it's not on my COA and if it's not on my label, it's not there at all. And that's just not true. But again, we are interested in, well, okay, everybody's looking at the major terpenes. what about all this other stuff kind of in the lower concentration? And so, and this is related going back to what is that skunky gassy aroma? People have been talking about the major terpenes for so long that if it was one of those, this question would have been answered a long time ago. But obviously it hasn't, and it wasn't.
So what you're saying is what you're saying that none of the individual terpenes that are commonly found in cannabis smell like that skunky smell.
Not at all. No. And so, like I mentioned, Abstrax, we a large part of our business is flavor and aroma based, right? And so we have basically every major terpene, even many of the minor terpenes in our lab, in our flavor lab. And so we can go in and smell these one by one. And so if you were to ever swing by our lab, Nick, you could do the same thing. And you would obviously say none of these smell like cannabis, or like at least that scent that we're all kind of after. And so, I think that's the benefit of our business model, is that we're able to leverage basically the flavor side to kind of validate the chemistry that we're seeing, spat out from our instrumentation. Yeah.
And so, I mean, when you're focusing on, there's many sort of different aroma notes that you can often smell in different cannabis products and different strains and things. This gassy, skunky smell, why is this one particularly important? Do consumers tend to fixate on that? Is there an association that's made in people's minds between like the potency or the quality of the product and that particular aroma note? Or, why is this one so interesting to focus on?
Yeah. So, I mean, I think you hit the nail on the head. I think many people who consume cannabis do use this specific scent. It's such a pungent smell. When you can get it that fresh, it's very pungent. But they use that as essentially a quality marker to their nose to say, is this high quality cannabis or not? Right? Is this, is this gas weed? Right? Is this going to make me feel a certain way because it has this aroma? And, it's funny because they're not necessarily wrong, because what we found in our studies is that these compounds are at the greatest concentration when the cannabis is fresher. So, people aren't necessarily wrong about that, where if you smell something and it is very pungent, it probably is a fresher product than if, you smelled something and it had a lower amounts. Now, that's not to say all varieties produce these equally, because they don't. And that's a whole nother story. But the point is that if people really enjoy this aroma, and I think they do that because it has this sort of, this time dependent manner as to the pungency of it, folks, that's the reason folks have really like honed in on it. But I also want to mention that I think there's another important kind of flip side to this coin here. So, those are folks who consume cannabis, oftentimes want this really intense aroma. But a lot of folks who don't consume cannabis, I would say, are equally as kind of, it's a nuisance odor to them. Right. Mm-hmm. And so in that context, understanding the chemistry of, this aroma within cannabis is probably the most important one to understand, because it's extremely diffuse, meaning that, you open a bag of cannabis, it's going to smell your entire room up, especially if there's a lot of these compounds in there. And so that means that, cultivators, breeders, even if you live in an apartment complex, right, this aroma is going to get around. And for people who don't consume cannabis, oftentimes it's described, like I said, as a nuisance odor. And so, that could have implications for zoning laws, policy, as well as potentially, do people suspect, oh, well, I can smell this in my apartment, I'm getting high from it. There could be actually, even though that's totally incorrect, there could be this sort of, these sort of issues kind of for non-consumers that I want to mention as well.
And so, you mentioned that no individual terpene smells like weed, basically. And, that's pretty well known to anyone who's ever smelled these things individually. And the explanation there that people have, which is not unreasonable, is, well, the olfactory system's complicated. There's lots of non-linearities involved in how our brains construct the perception of what we smell from the individual chemical molecules floating through the air and getting up our nose. So even though no individual terpene is responsible for like the core weed smell, at least that skunky smell. It's really the combination. So there's some particular constellation that might be associated with that smell. And it's really about the profile of all the terpenes. So has anyone been able to show that like different terpene profiles, different combinations of terpenes are associated with perceived quality or potency or this particular aroma or anything like that?
So I think that comes down to user preference. So, in your paper, Nick, you showed a really nice figure that basically grouped many varieties that are rich in D-limonene, caryophyllene, and myrcene kind of in the same bubble or the same kind of, group. But then you had these, what people would consider to be kind of sativa varieties in their own sort of classification. And I think in that respect, those actually terpenes do dictate those differences right there. And from that perspective, I think that just depends on, well, what do you prefer, right? But yes, in those situations, obviously the terpenes are mixing together to produce specific types of aromas. So in the sativa-rich varieties, they're nearly always terpinolene rich, and they have a very characteristic sativa aroma. So a lot of hazes, a lot of jacks, those sort of things, they all kind of have the same sort of background aroma to them. I will mention that they're very rarely skunky. They're kind of the outlier here in that context. But everything else kind of runs together. But you can still have that kind of characteristic skunky back note that's in there. And so your question of, do these things mix together to produce specific scents? Yes, but we're actually working on another paper right now that's going to basically kind of shed much more light on this in the context of the sensory aroma perspective. Mm-hmm. And so I think this next paper is going to be a follow-up to this one that just deciphered the skunkiness, but this next one's going to look into many other varieties of aromas that this plant produces. And I think it'll be very enlightening as to what is the actual impact of the major terpenes, even the minor terpenes, and then potentially all these other things that exist in cannabis as well.
So it's a fair restatement of that if you've got two distinct terpene profiles and two different cannabis strains, yes, they will have different aromas. You will be able to smell a difference between them. And that is coming to a large extent from the different terpene profile in one versus the other. But it's at best not clear that sort of skunky, gassy, pungent smell that is very strongly associated with cannabis it's not clear that that's coming from any particular terpene profile.
Yeah, no, and not any particular combination of them either, right? Like you mentioned, the olfactory system is incredibly complex, and people are just now starting to kind of understand how things work on a molecular level. There was a paper just published in Nature a few weeks ago that they finally worked out the crystal structure for one of the olfactory receptors in the nose, and they were binding a fatty acid to it. And so that's one receptor. How many more are there in the human nose? But you're right that basically what we showed is that these things these terpenes do not combine in any way to create that aroma, that skunky aroma.
So in the essential oil of the plant, which produces all of the compounds of interest, basically, it produces the cannabinoids like THC, which is where the psychoactive effects are primarily coming from. It produces volatile compounds like terpenes that float through the air that contribute to the aroma. You mentioned that the terpenes are the largest class of chemical compounds in the essential oil that are volatile, that are floating through the air. And then, of course, cannabinoids make up a big fraction of the essential oil, but they're non-volatile. Yeah. And you guys have sort of looked at other stuff in there that's not as abundant, but maybe important in different ways. And so why did you start to do that? And what are some of the key classes of compounds beyond the cannabinoids and the terpenes that are in that oil?
Yeah. So, I mean, that's exactly correct. Basically, the cannabinoids make up the majority of the essential oil content. Then you have terpenes that are usually like in cured inflorescence, maybe 1% to 3%. And then there's everything else. Everything else might total up to be 0.5% of the total mass, might be. But within there's hundreds of different compounds with different classifications as far as their functionality. And so, for instance, there's already been a few papers that have been published looking at kind of what are those other compounds? And so, there's esters are known, alcohols are known, ketones are known, aldehydes, all these sort of things. But again, these compounds, if you go either look at the aroma descriptors on like the Good Sense chemical database or PubChem, and you look at them, none of them will have that specific aroma that you're referring to, the skunky, gassy aroma. And so, esters tend to be fruity. They tend to be, they actually are essentially, the drivers in many fruits as to their kind of, unique flavors or tastes. Aldehydes are typically kind of sharp. They're more top notes, but they're still not going to have that pungency that we're talking about with the skunky, gassy aroma. Yeah. And so there's one other class. And so this is what we published on. And it was these volatile sulfur compounds that we ended up finding. Okay, these are the ones that look like they could be the correct identification as far as the chemistry behind that aroma. And, in our paper, we describe how we did that.
So what exactly are volatile sulfur compounds, and where do they show up in nature outside of cannabis?
Yeah, so VSCs are found in many different plants. They're in some vegetables, they're in some herbs, they're in some fruits, as well as they're in kind of unpleasant sources of smells. They actually add, I think it's hydrogen sulfide or one of the very small sulfur-containing compounds to natural gas, because it has such a low odor threshold. If there's a natural gas leak, you can smell it, because natural gas by itself doesn't have an aroma. So they add a tiny, tiny, tiny amount to that so you can detect it. In nature, though, so there are, I like to point out that there's animals as well that can produce this smell. So skunks can produce the smell. If you go look at the chemistry of their aerosol spray, they produce, I think it's like 20 to 30 different compounds that actually create that aroma. But then, like I mentioned, some vegetables also produce it. So things like garlic produce them, onion produce them, hops produce them. And they're all different. They're all kind of chemically specific to whatever plant that is. So even though onion and garlic are in the same family, this, what is it? I can't remember. Alliae or something. They're alliaceous plants, right? They produce still chemically distinct compounds that contain sulfur. And that's why they don't smell exactly the same, but they do still have a sort of pungency to them. Same thing with skunks. They're kind of chemically specific. And then in the fruit world, actually, there's some really cool, kind of typically tropical fruits that can produce these sort of scents. And so one of them that, here in the US, I don't know if people are as familiar with it, but durian, which is very popular. It's a fruit over in Asia, is extremely pungent. So durian people have looked into it quite a bit because it has such a noxious sort of smell. But it produces at least 5 or 6 different VSCs that each have kind of off-putting aromas. And it's so pungent that there are hotels over in Asia that actually have signs on the front doors that say, do not bring durian in here because it smells so bad that it'll essentially stink up the hotel. But then there's other things that are pleasant in the fruit world, such as passion fruit. So some of these tropical fruits that, you think of maybe putting in like a mojito or some sort of mixed drink, those oftentimes actually have a lot of their really pleasant characteristics are derived from VSCs.
So it sounds like, VSCs, volatile sulfur compounds across the board are, they're highly volatile. So they float through the air easily. They are highly potent typically. So a small concentration can be readily detected by the human nose. You mentioned the example of just adding a tiny bit of some of these compounds to natural gas so it can be smelled. Mm-hmm. And it's not, depending on the concentration and the specific molecule we're talking about, might be pleasant or unpleasant, but they often have a kind of pungency or a kind of kick to them. And very often it sounds like they are not pleasant to smell.
Yeah, I would say so. And again, like you mentioned, these things are very sensitive to concentration, or I'd say the human nose is very sensitive to the concentration. And so for an example of that is grapefruit mercaptan. So grapefruit mercaptan is one of the key compounds in grapefruit. And people will use in grapefruit, like drinks, like seltzers, that sort of thing. You might smell them. They have this weird kind of sulfuric note to them. That's grapefruit mercaptan. In the correct concentrations, which are extremely low, part per billion levels, it gives you that grapefruit note that, if you like grapefruit, you're really going to enjoy. But if it gets too high, it just becomes entirely sulfuric. And so we have this as an isolate in our lab. And if you open it, and usually it'll come at about like 1% dilution in the bottle. And if you open it at 1%, the whole lab just reeks of sulfur. From further away, where it might be more dilute in the air, it might actually smell like a grapefruit. But as you get closer to the source, it tends to take on this really pungent, kind of gross sort of sulfuric smell. So that's one example of that.
And you mentioned that VSCs are a key component of the aerosol that skunks produce. So yep. I think everyone probably knows what that smell is like, and how strong it is, and how long it sticks around, and how unpleasant it is. That's the whole purpose of that for the organism is to use it for a defensive function. So I guess a natural question is, if that's where the skunk smell literally comes from, what's the connection between the skunky smell in cannabis?
Yeah, right. I mean, when we framed it that way in our paper, it seemed so obvious what the answer was. It's like, oh, well, just obviously it's that after the fact. But I feel like that's all science, right? Everything's obvious after the fact. But yeah, so what we did is we use this advanced technology, this 2D gas chromatography, coupled with some fancy detectors, one of them being a sulfur chemiluminescence detector, which is only going to show us essentially compounds that contain sulfur in them. And so we measured a bunch of cannabis that had really high pungency as far as their aroma goes, and then really low pungency. And what we found is these compounds that were in the high pungency cannabis, so for instance, prenylthiol, they were in much greater concentration. And so, when we first did this, we went and sourced the material, and we opened in the lab, and it immediately was obvious that, okay, this is at least a very important part of that aroma, that gassy aroma in cannabis that we're after. Then you mix it with the terpenes, and it really, really starts to emulate that smell that, so many people really enjoy. But what's funny about it, you mentioned the relationship between skunks and cannabis, the skunky smell of cannabis. One of the key compounds in the skunk aerosol spray, it's essentially chemically identical to that in cannabis. The only difference being there's a double bond in one in cannabis and then not in the skunk spray. But having that slight chemical difference gives it it's not quite a skunk, right? I mean, I think most folks would agree that it has a skunky characteristic, but it's still not identical as far as the aroma goes to a skunk. And so that small chemical change basically is what kind of makes cannabis have its unique aroma versus that of like a skunk.
Okay, so you were able to have people rate how pungent they thought a particular cannabis strain was, and this was related to the concentration of some of these volatile sulfur compounds. How did you actually measure the pungency? Did you give people different cannabis strains and just ask them to rate it somehow? How did that work?
Yeah, so because we're a flavor lab, we've been developing a sensory panel internally over the last few years. And so what better opportunity to kind of flesh that out than understanding one of the most important aromas in cannabis, the skunky, gassy aroma. And so, in the lab at Abstrax, we got together a team. I think there was 4 of us at the time that were on the team. We didn't want it to be too broad, just to keep it more self-contained. But basically, we got them together. We had essentially a blind taste test done where, these are labeled with a code, and then they would go through and they would smell these and essentially rank them one by one. And so the way we did it intentionally was we put the most pungent first and then the least pungent second. That way, unbeknownst to them, they at least had kind of the bookends when they were doing the sensory on the remaining 11 samples. And so from there, they were able to kind of fill in what they thought was, the most, high pungency versus low pungency. And also we did have them also smell the prenylthiol, that isolate in particular, in the lab. So they're aware of this is the smell that we're wanting you to try to identify in cannabis. So they were trained to some degree. It wasn't as intense potentially as, other really deep sensory studies, but it was enough to really hone in on that one aroma.
Okay, and so you got really clear signal between pungency and chemical content, meaning that those two things basically track together. Most people rated the same strains as being the most pungent versus the least pungent.
Entirely, yeah. So the sensory, we saw a clear difference, which was good for us because that means if there's clear chemical differences between some of these compounds we're looking at, then yeah, we should be able to kind of look for some sort of relationship. And that's exactly what we saw, where especially using the sulfur chemiluminescence detector that only looks at these sulfur-containing compounds. If you we just plotted their intensities, their raw intensities as a function of that olfactory score that was obtained from the sensory panel. And it was almost, I don't want to say it was linear, but it was very obvious that there was a decrease in the olfactory score and the chemical composition kind of concomitantly. And so I think that was really good evidence for us to say, yes, these compounds definitely track, at least with the with the olfactory data. So that was a very good sign for us for sure.
And was there any relationship between the perceived pungency of a given strain and the type of plant it was, like the type of strain or the lineage it belonged to, or some aspect of its botanical classification?
Yeah. So, and this goes back again, Nick, to kind of like what your paper was saying. So one of the varieties was blackjack, which is a typical kind of Jack Herer smelling variety. And it did not have any detected VSCs, nor did it have a high olfactory score at all. In fact, I think everybody across the board said that they couldn't detect it at all. And so, yes, in that respect, there was, a difference between kind of like this classification you're describing and whether we saw them or not. But I will say that at the same time, some of these varieties we got, just from dispensaries and stuff, they also were at different sample ages. And so I don't want to say that, the lower ranked varieties weren't higher if they were fresher. Right. And so, that'd be like a false negative essentially for some of these varieties. Cause, if you go look at the paper, I think in the supplementary information, we list off the sample age for that very fact. So folks don't misconstrue that, Gouda berry, which is bred by, a pretty good, geneticist, had a pretty low score. But if you look at the sample age, it was about 160 days old versus some of the higher ranked ones, I think. So we actually did our own in-house cultivation study. So that was four days old, right? So it's not fair to compare it in that respect. But again, as far as the kind of the chemistry goes as to the classification, the blackjack for sure was relatively fresh, terpinolene rich, no CSCs, but all the others were not terpinolene rich. And they did have CSCs, at least to some degree.
Yeah. So there's a relationship between the concentration of these volatile sulfur compounds in the sample with the perceived pungency from human observers, as well as how old the sample is.
Yes.
And can you talk about that a little bit more, how old the sample is? What exactly does that mean? Does that mean it was harvested at a particular time in the plant's life cycle? Does that mean it sat around after it was, harvested and cured and all that stuff? How do all those factors tie into this?
Yeah. So every single step of the way is going to factor in, right? Because the chemistry is going to happen regardless, right? And so in our paper, we showed that basically we did a growth study. And so we tracked these as a function of plant growth through cure and then just like 10 days after curing. We saw a rapid drop within those 10 days, and those were stored in some nice, glass jars, right? There's not Mylar packaging or plastic baggies, yet we still saw a pretty significant drop. And so I do think that the fresher the sample, obviously, the more of these compounds there's going to be. So if you're not getting something until 160 days later, it's not going to be the same representative product that it was, after 4 days. And so, I think you might be alluding to the fact that a lot of folks who go to the dispensaries, oftentimes they'll have two dates on them. There's the harvest date and then the package date. And so, this is a huge thing because we know that even in really nice packaging conditions, about a week afterwards, these compounds have dropped pretty significantly, and they most likely continue to drop like that. And so if your harvest date is, January 1st, but your package date is not until March 1st, that's about 90 days worth of time that's already passed that a consumer could even get their hands on it. And so from the context of quality and, really getting something that you want to be representative of your product, that time between harvesting, curing, packaging, and then on the actual shelves, you want to minimize that as much as possible because this time dependence is so rapid.
Yeah. And the other thing that's interesting here that we've sort of alluded to, I'll take a minute to unpack it and then I'll have you build on it. So in the paper that I did with some colleagues that was published a year or two ago, basically we took all the terpene content that was available for testing labs across, many, many thousands of cannabis cultivars, actual cannabis flower that goes to dispensaries and is purchased by consumers. And like overall, what we found is that the relationship between how the industry classifies this, so is it an indica, a hybrid, or a sativa, and terpene content, there was no relationship there overall. So like the average indica doesn't have a terpene profile that differs from the average sativa on average across the whole data set. But, we used some, different analytical techniques to cluster or classify into different groups all of the cannabis strains based on their terpene and cannabinoid content. And so when you do that, a couple of, the two most distinct groups are basically characterized by having either very high levels of terpinolene together with, a terpene profile that's associated with that. And then all the other ones, which are, a wide range of terpene profiles, but they all share in common very, very low levels of terpinolene. So you've kind of got two groups. One of them is really big. Most strains have very low levels of terpinolene and some diversity of other terpene profiles. And then, around maybe 12%-ish of the other stuff that's out there has very high levels of terpinolene. And this is the one area where we found a relationship between the indica hybrid sativa classification that the cannabis industry uses to label consumer products and the chemical profile. The high terpinolene strains, the ones in the minority in terms of how common they are, tended to have an overrepresentation of sativa dominant cultivars or names and an underrepresentation of indicas. And, it was really cool when you showed your data at that meeting we were both at together with my data is that high terpinolene group that has a more sort of sativa bias to it in terms of the cultivars that belong to that group. It included things like the Jack strains. So like Black Jack, the one that had a very low pungency score in your study, Jack Herrera, XJ13, all these things like Lemon Haze or Super Lemon Haze. And so that was really interesting. And one of the things that's interesting about that is, as I'm sure but for listeners, sativa varieties in like the botanical sense, they tend to produce smaller harvests. They produce, less massive buds, and they take longer to mature. So those strains with the high terpinolene profile are probably either being prematurely harvested or, the sample's sitting around longer by the time it gets to the consumer. And so I'm wondering if you could comment on that and sort of tie some of those things together.
Yeah. So, that's an interesting thought. I actually hadn't considered the fact that, harvesting kind of not at the quote unquote incorrect time, if you're on a set schedule for the sativa varieties could actually be impacting this. That's very true. But I will say, so we measured hundreds of different terpinolene rich varieties in our lab. We've also extracted the essential oil using different distillation techniques. So we've been able to concentrate it down to look for those compounds, and we've never seen them except for there's one variety that we did, Durban Poison, which I think is still interesting because I think you mentioned something specifically about Durban Poison in your paper. But the point is again, that these things kind of have their own unique botanical characteristics, like you were mentioning, that are kind of different from all the other varieties. And at the same time, they obviously have this difference in chemistry as well. So this lack of these volatile sulfur compounds that, in the context of cannabis, we call these cannasulfur compounds because they're so specific to this plant as well as they're so important. But we've essentially never seen them in those terpinolene-rich varieties. But in everything else, caryophyllene, limonene, ocimene, all the classes you showed that were grouped together in that other cluster, we have seen these at least to some degree. Now, that's not to say that there are other varieties of sativa like terpinolene-rich varieties beyond that Durban poison that has them, but they're few and far between. And so, hey, for folks who don't like that skunky smell, I think those would be a better option perhaps to consume at that point.
And so these volatile sulfur compounds, so they seem to be responsible for this pungent, skunky odor. They vary systematically across different types of strains from different lineages. Mm-hmm. They're low in some, they're higher in others. They also vary as a function of how old the sample is. So, they go away quickly. And so that also sort of nicely ties into how easily many seasoned cannabis consumers can detect freshness. Like I have many friends that are, weed connoisseurs, and they can pick up a sample, and if it's more than a week or two old, they can tell with one sniff instantaneously that it is that old or that it is fresh. And so it's remarkable sort of how the sensory side ties into some of the things that you guys have seen on the chemistry side. What else can you tell us about these VSCs that might be important? So beyond their pungency and their contribution to the aroma, the sensory side of this, do they have any interesting known pharmacological or medicinal properties?
Yeah, so I think there's a few uses for these potentially, in the future. So the first thing that, you mentioned the medicinal aspect. So one relationship to another plant that we've mentioned in this discussion is garlic. And so back when I was a grad student, for some reason, I was looking into the chemistry of garlic. I think I just wanted to kind of understand, why people say it's so healthy and all that. So when we finally worked out the structures for these in cannabis, I remembered, okay, these things look remarkably similar to those that are found in garlic. And so if you go and look, basically, it's just a slightly more lipophilic version of the compounds that are found in garlic. And so diallyl sulfide is found in garlic, diallyl disulfide. These are some of the most important compounds in garlic that give some of its purported sort of therapeutic sort of benefits or dietary sort of benefits. And so if you go look through garlic literature, there's quite a few different bits of research that are looking into those aspects. And so there was a nice study, I think it was in 2008, that basically showed that, I think it was diallyl disulfide, which is in garlic, like I said. It's one of the main reasons for why it can help with your blood pressure. And so structurally, cannabis has something very similar. It has diprenyl disulfide. So that you just have these two methyl groups on the terminal allele that is in garlic. And so, that chemical similarity and the mechanism that they proposed should honestly hold true for the compound that we found in cannabis. Now, I'm not saying that smoking weed is going to lower your blood pressure at all. And, these things are in low concentration, but the fact that they're there and the fact that they have this sort of chemical similarity to other, potentially useful compounds in other plants, leads us to want to investigate, okay, well, do these compounds have any sort of benefit? But another thing I'll mention is that, in garlic, well, you don't smoke garlic, and I don't recommend that, but you do smoke cannabis, or you can vape cannabis, right? You can inhale it. And the fact that you are taking in these compounds in that way, I think is interesting versus orally with garlic, because, Nick, as you're aware, I think you did neuroscience in your background, that, how you get a chemical into your body will definitely affect kind of the metabolism of, what happens to it when it's in the body. And so the fact that we are inhaling these compounds versus, consuming them orally may actually kind of unlock some of those sort of benefits that would be otherwise lost if you were consuming them orally.
And so how would you, there's sort of this persistent problem in the cannabis industry where, we've got this legacy classification system that people are very used to and comfortable using, indica hybrid sativa. For those who don't know, the basic the central dogma of consumer cannabis is basically, there's three types of cannabis. Indicas are one type of cannabis strain. They have certain physical and botanical properties, and those strains tend to have a more relaxing or sedating effect. There's sativas, which are basically the opposite. They have different botanical and growth characteristics, and they're more energizing or stimulating in terms of their psychoactive effects. And then there's hybrids, which are just, a hybridization of the two, and they fall somewhere in the middle. And it's a really simple way to try to explain a complex, multifaceted landscape of hundreds or thousands of allegedly distinct products to consumers, right? So it's a really simple way to talk about something that's really complicated. But on the other hand, the relationship between the chemistry and these industry labels is basically a mess, and it doesn't make a lot of sense. So, knowing, after doing all the work that you did and the work that I and others have done, looking at terpenes, looking at cannabinoids, looking at these VSCs that you guys looked at, if you were to, if you could sort of wave a magic wand and it's like, okay, we're going to use the terms indica, hybrid, and sativa because those are so ingrained and so sort of easy to use even for the average person, but we're going to standardize what gets called what. Which chemistries, which profiles would you label as indica versus sativa in a way that you think is most sensible?
Yeah, I mean, this is a huge issue in the industry, right? We don't want folks to have a PhD in chemistry or biochemistry to have to buy a product, right?
If you're hearing this, you are listening to a premium episode of Mind and Matter. The first part of premium episodes are freely available to all listeners, and the full episode is available to premium subscribers at mindandmatter.substack.com. Premium episodes feature conversations with startup founders, executives, and other professionals at science-related companies. They involve discussion of not only the science and technology underpinning their businesses, but also other topics such as business operations and strategy, startup funding, and the practical applications around how they're using science and technology to create products or services to solve customer problems. Premium subscriptions help sustain the podcast and increase the quantity and quality of the content that I produce. However, I do not want anyone to miss out on learning from any of my guests just because they can't afford a paid subscription. If you're interested in hearing full premium episodes but can't afford a paid subscription, simply sign up for my free weekly newsletter at mindandmatter.substack.com. Send me an email and I will give you a free premium membership. As always, I thank you for your support. No matter how you engage with Mind and Matter, the simplest and most effective way to provide support is to share your favorite episodes with family and friends. This episode is supported in part by Athletic Greens. Their main product, AG1, is a comprehensive and convenient daily nutrition product containing 75 vitamins, minerals, and whole food sourced ingredients with less than 1 gram of sugar per serving, no nasty chemicals or artificial anything. It's gluten and dairy free and compatible with paleo, vegan, vegetarian, and ketogenic diets. AG1 is a quick and convenient way to supplement your diet to help ensure your body is getting the nutrients it needs. It comes in powder form and you can mix it in water and drink it, or you can put it into a smoothie or a shake or something like that. I mix it into water and drink it with the first meal of each day, and it's super convenient. If you go to athleticgreens.com/mindandmatter, Athletic Greens will give you a free 1-year supply of vitamin D and 5 free travel packs with your first purchase. Their vitamin D product comes in tincture form, so you just take 1 drop each day. A large fraction of the population is actually vitamin D deficient, especially in winter months when we get less sun exposure, and vitamin D is super important for the proper function of the immune system and for a variety of other things. And there's even evidence indicating that vitamin D deficiency is correlated with more severe cases of COVID-19 in those who get infected. Every time I go into the doctor each year for a checkup, I'm always told that vitamin D deficiency is very common and I should be supplementing on a daily basis. So visit athleticgreens.com/mindandmatter or click the link in the episode description. You'll get a free 1-year supply of vitamin D with your first purchase.